Today we're going to be looking at geometric functions. Now the big thing to know is that we have spent the entire first semester working on linear functions. Linear functions are arithmetic sequences. So when it says arithmetic sequence, what it's really talking about is whenever we can add the same number over and over again or subtract the same number over and over again. So right here, we're actually subtracting 4. And again, we're subtracting 4. So this is an arithmetic sequence. It has a common difference of -4. That's what we subtracted every time. Now, geometric sequence is going to be a ratio. So instead of adding or subtracting, we're going to be multiplying. So in this one, our ratio is what do we multiply to get from 1 to 5? We multiply times 5. And from 5 to 25 times 5. So our common ratio, what we're multiplying by, is 5. And now the thing to note here is it's got to be multiplied. Sometimes you're going to get in a situation where you want to divide. And when we get to one of those, I'm going to show you what you do because it has to be multiplied. So put a little star there or something and just say, must be multiplied. Okay, so first thing it's asking us to do is determine if each sequence is a geometric sequence. Remember, geometric means we have to multiply. And if it is, what is the common ratio? What are we multiplying by? Or if not, explain why. So let's start with the first one. To get from 1 to -4, we're going to multiply times -4. Now we're just going to check to make sure that's the pattern. So -4 times -4 is +16. +16 times -4 is -64. So it is a geometric sequence, and our r equals -4. So we can cross out the no. Okay, number 2. When I look at this, we're not multiplying here, we're adding. We're adding 4 each time. So no. No, because we're adding 4 each time. Okay, now number 3, let's look at it. Number 3, we're multiplying. Every time we're multiplying -2. So our common ratio is -2. And we can cross out the no. So on number 4, it's asking us to write the next 3 terms in our sequence. So a couple things you need to know is what a sub 1 means. That little sub 1 is saying that's the first term, term 1 in our sequence. So it's telling me that my term 1 is 2. So my first term in my sequence is 2. And then my ratio is telling me that I'm going to multiply the number in my sequence times 1/2. So 2 times 1/2 is 1. 1 times 1/2 is 1/2. 1/2 times 1/2 is 1/4. So just using the ratio they gave me and my starting term, I was able to write the next 3 terms in my sequence. So let's look at a sequence, how it looks in a table. So we'll make this a little bit bigger. Okay, so to put my sequence in a table, I'm going to put the 6, 12, 24, and 48. And that's my term number 1, 2, 3, 4. So let's just look. What is my first term of this table? What is my a sub 1? Well, my a sub 1 is 6. It's that term right there. And then let's figure out what our ratio is. 6 to 12 is times 2. 12 to 24 is times 2. 24 to 48. So my ratio is times 2. So we're not going to graph this one, but let's turn the page and go ahead and metric sequence formula. This formula we're going to be using to figure out different terms in our geometric sequence. So let's just look at the formula because it looks a little scary, but once I explain it out to you, it's really not a scary formula. So first it's saying a sub n. This sub n is just saying the term n. We don't know which term. So a for any term we want to put in, n being our term number. Now let's look at this a sub 1. We've already seen that. That's the first term. So that's the first term. And then r, we've already seen that also. That's our ratio. So the only thing we really haven't seen is we're raising this to the power of n minus 1. N being our term number minus 1. So when you break it down like that, it's not a real scary formula. So let's look at number 6. And I'm going to go ahead and just kind of put this to the side so you can see 6 is not part of our sequence. That was actually the problem number. So my sequence is 3, 15, 75, 375. The two pieces of data I have to have are what's my term number 1 and what's my ratio. So term number 1 is 3. And if I look, I'm multiplying this times 5 each time. So my ratio is 5. Now it's asked me to write an equation for the 6th term. The reason I know it's a 6th term is because they put that little sub 6 there at the bottom. So my equation is the first term times the ratio raised to the power of the n, which is 6, minus 1. So when I put that in my calculator, I come out with my 6th term is 9,375. That's the 6th term in this particular sequence. Okay, number 7. Number 7. First term is easy, 2916. I can see that that's the first term. But my ratio is a little harder. And remember how I said you're going to get to a place where you want to divide, and I'll show you what to do? We're at that place. So if you look at this, most people go, well, look, 2916 divided by 972, and you come up with you want to divide by 3. So we want to divide this thing by 3. But as I told you, the ratio always has to be multiplied. So we need to figure out the fraction that we're multiplying by. So if you figure out you want to divide by 3, go ahead and just put your divided by 3 and put a 1 on top. That's the fraction that you'll be multiplying times. So our ratio is 1/3. So now let's write our equation. We're looking for the 6th term. That's what that little 6 means. So our first term, parentheses, our ratio, raised to the 6th term minus 1. And when we put all of that in, our 6th term is 12. Okay, so on number 8, they've actually given it to us as a graph. The problem with the graph is it's difficult to see patterns. So I always start by taking my graph and writing it as a table. So my points are 1, 3, 2, 6, 3, 12, 4, 24, and 5, 48. Now it's easy for me to see the patterns. So my first term, a sub 1, is 3. My ratio, I'm multiplying each time times the number 2. So my ratio is 2. So to write my equation, I'm going to take my first term times my ratio raised to the power of 6, because that's the term I'm looking for, minus 1. Okay, and then the last one, we're actually looking at a situation with clicks on a map and how big it zooms. So let's start by just getting our information. We know our first term is 5, and our ratio, 5 times 2 is 10, so our ratio is 2. And we're going to write this as A sub n equals our first term times our ratio raised to the n minus 1. Now, this is actually giving me my y value. And it's asking for what my x's are. How many x's will it take to get to 640? So I could sit here and keep multiplying times 2 and just keep going till I get to 640. Or I could put this into the y equals of my calculator. So to put it into the y equals, let's just look at how that would look. This is going to be my y, so y equals 5 times 2. I can't put an n into the y equals, so that's going to have to change to x minus 1. Now if I put that in the calculator and go look at my table, when x equals 8, y equals 640. So I know it's going to take me 8 clicks to get my map to the 640 miles. Okay, so that's it for the notes. If you have any more questions, come in for tutoring.